Gregory and Arrhenius. Perhaps you still remember. And the acid and base, strong and weak. One have to memorize it easier. Do you still remember which is the acid? I will explain once again this. Okay, buffer solution, the hydrolysis, the application, and the examples. Okay, what is acid and base? Acid are chemical substances that release hydrogen ions, H plus, when dissolved in air. No, not in air. I'm sorry.
Water.
Yeah. Sorry. Yeah. Sometimes my brain is a bit dismantled. Okay. Typical properties of acid include the shortage, the ability to corrode metals, and turning blue litmus paper. Do you know the litmus paper?
To find the pH.
Yeah, to find the pH. The paper to find the
Oh.
pH. And turning red when we add some acid, and turning blue when we add some bases.
Yes.
Okay, some example of acid include hydrochloric acid, HCl, in our stomachs, and citric acid in various fruits. Some of fruits is contain of acid, like lemon, or I don't know. Sometimes a lemon is with the bubble. Some say there is a basis, and some say there is a acid. Even though the taste is sour, but some people say that lemon is not acid. It's a basis, and it's safe for ulcer. Okay. Bases, on the other hand, are substances that tend to produce hydroxide ions, OH minus, when dissolved in a, once again, in water. Okay. Bases often have a bitter taste, feel slippery to the touch, and can change the color of litmus paper from red to blue. For example of bases include sodium hydroxide. Sodium hydroxide soda or AOH, and ammonia, NH3. Perhaps you already know about this. How can I say this agent? This compound. Okay. Do you know the differences between the atom and compound?
Compound is groups of atom.
Yeah, the groups of atom. It can be same atom, or it can be different atom. So we say compound. Theory of acid and base from the first theory is Arrhenius. Uncle Arrhenius said that acids are substances that produce H plus in solution, and bases are the substances that produce OH minus in solution. So just think about the acid is somebody that rich. Produce H plus. The characteristic of acid, an acid, is that when it dissolves in water, the substances will ionize into hydrogen with a positive charge. Yeah, the negatively charged ion is the remaining acid. Do you understand from this statement? Okay, then the characteristic of a base is that if it is in a water solvent, the substance will ionize into hydroxide ions which have a negative charge. And the positive charged ion are called base residue. Is the remaining acid and the base residue. Asam sisa. Yeah, the remaining acid. So from the Arrhenius, we studied about okay. Perhaps you still remember about this one. Monoprotic and do you still remember what is monoprotic and diprotic? Oh, come on, you just last week and this week you already. Okay, what is monoprotic? That contain
I don't think we studied that last week.
really? Okay. Plus when we know that principle, so we can solve this equation. NH4 plus
Amin.
yeah. When we say which one the acid and which one the basis. This one is acid and this one is base. Because this is the acceptor and this is the
donor.
Yeah, this is the donor and this is the acceptor, right? Yeah. The difference, the difference atom of hydrogen, only just one atom. Yeah. The donor, one atom, and yeah, is it is except just one atom. Yeah. Minus one atom, and this is just one thing. Okay, only one atom of hydrogen. You can, did you call it is rings the bell? I don't. Do you still remember
Oh,
from the school? Amphoteric. What is amphoteric? What is called the reaction name? Amphoteric compound, and then the reaction is amphiprotic. 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 The compound of the amphoteric with amphiprotic reaction. Amphiprotic reaction. Yeah, the reaction is called amphiprotic. What is amphiteric compound? The compound there?
Decompose.
The compound there?
Produk reaktan.
Come on. The compound there
Reacts
reacts.
with nggak tahu. Oh,
They can be an acid and they can be
base.
a base as well. So we can say amphoteric.
Reacts with acid.
Yeah. Like the popular one. H2SO4. So we can have H2SO4, then we say this is the acid type. Acid from Bronsted-Lowry principle, they have to turn off the H or the hydrogen atom. So before they can be acid, I mean like how to say, this is the amphoteric compound. So it can be a dual like acid and base acid. So when we how to say it, when we can reduce the H, so it became the HSO4 plus this is the Q minus and then sorry. Okay. Yeah. Oh yeah. Like this. So when we studied about where can the SO4 can be have 2 minus is from this reaction. H2SO4 and then HSO4 minus and then HO42 minus. Yeah. When we say this is the acid, so this is the base. And this is the in the base of the HSO4 minus, they became the H2SO4. And then when the HSO4 minus, we leave the H, or we became an acid, became a base, and then we accept her, we leave the H. So we found that SO4 is have 2 minus of ion. So SO4 is always with 2 minus. The 2 minus is from this what is it? Turunan derivation. From this derivation. What subject before this subject?
Algebra linear.
Algebra linear.
With Mr. Iwan?
Yes.
Okay, what else? Okay. Do you know what the compound is? What is the compound? How can we call this?
Potassium. Peroxide.
This is the amphoteric compound. Also. How can we call it? How can we call this compound? What's the name of this compound?
Apa dia? Hydroxide. Fosfat. Iya. Acid fosfat. Asam.
What is it?
Is it hydrogen phosphate?
Hydrogen phosphate. Hydrogen phosphate. This is the amphoteric. So when the H when we leave just one H, so it became H2PO4
Minus.
minus. Then HPO4
2 minus.
2 minus. Then PO4
3 minus.
3 minus. So we know and we have to remember that PO4 has 3 minus. It's the same with sulfate. SO4 2 minus. So this is why the SO4 sulfate is have 2 minus of iron, and the phosphate is have 3 minus of iron. It's from this derivative.
So it's still the same as H3PO4. It's just like the
Yeah, this is the compound when we add some acid.
okay.
When we add some acid from the phosphate or the sulfur. So right now you know very how to say, and we say it indigenous. Acid-base theory. The conjugate acid is the base that gains a hydrogen ion, while the conjugate base is what remains after the acid gives up a proton in a chemical reaction. These two are called conjugate acid-base pairs. Okay, the third one is Lewis. Lewis said it's different with Bronsted and Lowy. Lewis said that acids are electron pairs acceptor and bases are electron pairs donor. Yeah, it's the different between the Bronsted, Lowy and the Lewis. Yeah, this is the opposite from Bronsted Lowy. Lewis acid and bases explain their structure and bonds. They have bonds, yeah. According to Lowy, acids are substances that tend to accept base electron pairs. Base electron pairs. So we know the electron pairs. While bases are substances that donate electron pairs. So we can call it the free of electron pair. FeP. Free of electron pairs. Do you know of the NH3? H3 and BF3. Okay. From the how to say it? Sorry that I forget. Yeah, from the topic of the chemical bond. Do you still remember? What are they?
Chemical bonds.
Chemical bond. Perhaps from Mr. Oyo.
It donors electron to the
Yeah. The type of the chemical bond that you know. Yeah.
Maybe hydrogen bond
Hydrogen bond.
or ion.
covalent bond.
Covalent bond.
Yeah.
Oh, I ionic bond.
Ionic bond.
Yeah.
Covalent bond is the bond between what and what?
Non-iron,
Non-iron and
Non-metal and metal.
non-metal
And
and
non-metal.
non-metal. Yeah, the covalent bond. So from the chemical bond, I think you know about the. I don't know. I'm worried that this is not the phrase of English. The atom hole. From the chemical bond, you have to know the atom hole. So which one the atom hole from this? From this compound?
And
N. Why N?
the least amount of
The least of the atom.
yes.
This is just one atom, and this is three atoms. So the atom hole is the N. In what group N is?
Alkali.
From what group? Come on. This atom from the A group of periodic table have to memorize until death.
2A.
You have to memorize all of the A group of atom from the periodic table until you death. Ya hafal mampus keduanya. Come on. From what group? The atom in. Huh?
5A.
5A. So we have 5, yeah. And then H from
1A.
1 because this is 3 and this is the and it's okay. Okay. Write this one. This is H. We have 3 H. The H is from one group of 8. And then the 5 have 5 group of 8. So I take this 1, 2, 3, 4, 5. Okay, and then the B and F. Which one the atom hole?
B.
B. In what? And in which group? This atom? 3. Okay, and for the F, we have 3F. From which group of the F? 7A. So we have 7. 1, 2, 3, 4, 5, 6, 7. Yeah. Then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And B is from
3.
3.
3.
3. Okay. I put this the bond 1, 2, and 3. From this, which one is have the free electron pairs that have no bond between the atom among the atom?
Have free electron.
Free electron pairs.
NH3
NH3?
has.
No, only the N. Yeah, this is the free electron.
Yes.
This is have the bond. This is the bond with this, and this is the bond with this. So because N is from 5A. So 1, 2, 3, still remain 2 of electron pairs. So this is the free that can be turned to the BF3. There's no atom anymore. There's no atom remaining anymore. B is from 3 group. Okay, so 1, 1, 2, 3 is already have the pairs, and there's no atom remaining to be tolerated. So it is clear. So we know of the free electron pairs, the concept of free electron pairs. Okay.
So BF3 doesn't have free electron pairs because there's no atom left.
Yeah, there's no electron pairs remaining from the BF3. So the compound that still has the free electron pairs is in H3, the N1. Yeah. It must be pairs here. Pairs. So we have 2 electrons free, no bond, jomblo. Yeah. Okay. Okay. The next is the types of acid and base reaction. First is the neutralization reaction between acid and base that produce salt and water. For example, hydrogen chloride, HCl plus natrium, how to say it in English? Natrium hydroxide, yeah, and became natrium chloride plus water. So, natrium chloride is a salt. Okay, the salt is the natrium chloride. This is the kitchen salt. Yeah, this is the coincidence. This is the kitchen salt. So I just want you to know more about the salt. Salt is not just natrium chloride. So what is salt actually? Okay, salt is not just the kitchen salt that we found in your mama's kitchen. So salt is the reaction between acid and base. It's always produce salt and water. So what is salt?
The residue of the
residue?
The base and acid reaction.
Yeah, from the reaction of acid
and base.
Or the reaction between base and acid. It's the same. Produce salt and water. And the next reaction is acid with metals. Acid with metals is produce salt and hydrogen gas, like zincum plus sulfate acid and become zincum sulfate plus hydrogen. Then, do you still remember this? Yeah, how to the easy way to memorize the acid. Yeah, acid and base that are perfectly ionized. Yeah, the definition of acid and base. Yeah. Acid and base that are perfectly ionized are called strong acid and strong bases. Perfectly ionized. It's called strong acid and strong bases. While those that are not perfectly ionized are called weak acid and weak bases. For example, if you drink an antacid solution as a stomach ulcer medicine, do you have an ulcer in here? Is there anyone that have an ulcer in here? Ulcer, you know ulcer? Sakit mah. No? Yeah. Sometimes when the patient have an ulcer, we have to take some medicine that say that it's called antacid or antacid. Yeah. When you drink an antacid, we can taste that the water and the compound is not perfectly dissolved. Sometimes we can taste like a powder in the solvent, in the solution. Yeah, we can say the powder in the solution. So when we say in the powder and in the solution, we can say that the compound is not perfectly ionized. So there is say that it is a weak basis because antacid we have we have the formula of the antacid is magnesium hydroxide. Yeah, magnesium hydroxide, and we can take composite to be a magnesium 2 plus and 2 of hydroxide minus. So magnesium hydroxide is a weak basis because they can perfectly ionize. How can we can say that this is a basis?
OH.
Yeah, OH. And yeah, that it's contained in the weak basis in here. So the easy way to memorize this is just CFP, the compound that contain atom C, atom F, and atom P is always a weak acid. And we can know it is a weak acid from the atom of the oxygen and the hydrogen is less than 2. So when we say this, H2CO3, how many oxygen atom in H2CO3 in here?
3.
3. And then the hydrogen? 2. So 3 minus 2 is 1, and 1 is less than 2, so this is the weak acid. And then the strong acid. Strong acid, it's the components is from 7A from periodic table. The atom from 7A of periodic table. Cl, Br, and I. When we add some H in front of this atom and become an acid, we can say that this is the strong acid. Chlorine, bromine, and ion. The ionized formula, ionized. How can I say it? How can I say it? And you know the Ka and Kb is an acid and this is a base. Yeah. Okay. And then, yeah, calculation of pH buffer solution. Yeah, the buffer solution. Definition: a solution that can maintain its pH from the effect of adding small amount of acids. Yeah, just remember, buffer solution is the solution that can maintain its pH from the effects of adding small amount of acid and small amount of bases and dilution. So when they dilute with some small amount of acid or some small amount of bases, they can stay with the same pH. Okay, this can be done in two ways. The first is in direct ways. We can the requirement is weak acid when we want to make it direct. Yeah, it contains weak acid and salt or base conjugation, and weak bases and salt, it's acid conjugation. And indirect is must be reacted first. Yeah, with weak acid plus strong bases and weak bases plus strong acid. The requirement is the strong bases and the strong acids must be finished reacting first. Finish react until zero. Yeah. So we can say that the weak of the molarity of the weak one is always more than the strong one. The molarity of the weak one is always more than the strong one. Okay? Okay, this is the formula. Yeah, you have, you know this formula from the Henderson or Hasselbalch equation. Yeah, pH is and pOH. And the last one is hydrolysis. Hydrolysis, we can add the hydrolysis in our test, but I just want you to know what is the hydrolysis, and sometimes you can be perplexed with hydrolysis and buffer. Which one is buffer and which one is hydrolysis? So the hydrolysis is the reaction of salt decomposition in water, which form positive and negative ions. These ions will react with water and form acid and bases. In salt hydrolysis, water is formed when an acid and a base are mixed. Yeah. Not all acid and bases mixed in water experience that calculation of salt hydrolysis pH. But the condition for calculating the hydrolysis pH have the requirement this. Salt comes from a weak acid and a strong base. Weak acid and strong base. Or from strong acid and weak base, or weak acid and weak base. What about the strong acid and strong base? Strong acid and strong base have no hydrolysis reaction because the pH of the salt is neutral 7, so there's no hydrolysis reaction from strong acid and strong bases. Did you understand what I mean? Okay. And then the differences between hydrolysis and buffer. One is in the calculation of hydrolysis buffer and hydrolysis and buffer pH, both use the MBF concept. MBS is in Indonesia. Mula-mula bereaksi sisa. How can say it in English? It's very tiring when we have to think in English. Initial reactive reminder, or ERR, it's okay. Not MBS, but ERR, it's okay. The calculation of hydrolysis pH in the reminder one, sisa, section will leave the number of moles of salt and water in the product section, while the number of moles of acid and base have finished reacting in the reactant section. So the calculation, the calculation of buffer solution pH in the reminder section will leave the number of moles of weak species, weak acid or weak base, it depends, salt and water, while the number of moles of strong species, strong acid or strong base has finished reacting. This is the example. Is it ring the bell? Okay, you can say it is the initial reactant and digest. Hydrolysis is when the weak and the strong one is already empty or reactive or finished reacting. But from the buffer, we still have the remain of the acid, the weak of acid or the weak of base. Okay. Do you still understand what I mean?
Yeah.
Okay. So this is the application. Strong acid, weak acid, and strong bases, weak bases, and this is. We don't have any time anymore, so perhaps you can study by yourself. Okay, just one question. Question 1. Which one is the buffer solution from the following solution? Which
one is buffer solution?
What is the buffer solution definition? Solution that the solution that come on.
The point is like it's not neutral, but it's reduced. Like for example, some atom has a mole of this, and when it's reduced, it still has some mole.
Not mole. We say it about the pH.
The pH.
Yeah.
It's not neutral. Okay.
Just googling it. I already conveyed to you. Just Google it. We just add the digits still in the pH, and the small amount of base just add or decrease, increase or decrease just 0.2. Okay, yeah, this is the question 1, and this is the question 2. You have to make a calculation first about this, and this is the question 3. This is a bit complicated, but not too complicated. Yeah, next week perhaps you will have the answer. Okay, is there any question or comments from this topic?